Hey guys, this is the second part of our 4.4 lesson on Earth. There are four basic things that I want to cover here in the second half. Let's take a look at them. The first one is Earth gains and loses mass. One of the things that eighth graders talk a lot about in science is the concept of mass. We start with the word and discuss its definition. What is mass? And then we go into how mass is energy and how energy changes and moves and affects things around us and is in us. And we go into more detail about some of the actual formulas for mass and movement, speed, velocity, and things like that. But for this lesson, I just wanted to say that Earth gains and loses mass. Mass is made up of matter. Anything that takes up space and is made up of matter is called mass. Okay? Well, the Earth gains and loses mass on a consistent, ongoing basis. It's always gaining and then losing mass in various and different ways. The way that it can, for example, can gain mass is through the impacts of meteorites and comets. When those things fly through the sky, and meteorites don't hit the Earth very frequently, but smaller parts hit the Earth rather frequently on a daily basis. Little pebbles hit the Earth from the sky around us and from our solar system. And we just don't know it. Most of those end up in the ocean and on the deserts because that's what makes up most of the face of the Earth. But that's one way that the Earth gains mass. In other words, it becomes heavier, if you want to think of it that way. And a way that the Earth loses mass on a regular basis is through the escape of gases into space. Now, in your mind, you may be thinking like, well, gases, I thought you were talking about things that have weight and take up space. Well, guess what? Gases are matter. Gases are matter. They are made up of particles, therefore they are mass, they are matter. And they escape into space on a regular and consistent basis. So again, one of the ways that the Earth gains mass is through incoming meteorites and comets. That's just one way. And then one of the ways that it loses mass is through the loss or the escape of gases into space. Let's look at the second part of this. Earth's systems, and remember we talked in that first video about the systems of Earth. Earth's systems interact over a wide range of scales. Now in your math class and Mr. Garth's class, I know that he's talking about scales, okay? Let me read this again. Earth's systems interact over a wide range of scales. What am I talking about when I say that? Well, one of the microscopic scales of an example of Earth systems interacting, microscopic scales, there's interaction of bacteria, which are single-celled organisms, interaction of bacteria. So that's really microscopic in size. They can last, the Earth systems interacting can last from billionths of a second. An example of that would be lightning, all the way up to billions of years. Those interactions of continental drift, which we have talked about, those took place over billions of years. So again, Earth systems can interact over a wide scale of a wide range of scales, okay, from very, very small to very, very large. Now, essential support systems for life. Maybe some of you can guess what I'm talking about. Essential support systems for life. What are those called? Ecosystems. Ecosystems. These systems are dynamic, which means they're changing all the time. Now, some parts of ecosystems remain the same for millennia, which is a long period of time, thousands and thousands of years. Okay, while others change and react and move frequently. For example, the Earth's climate, there's that constant change of climate. So that part of ecosystem changes on a regular and consistent basis. Let's look at the third part of this lesson, or the third part of the second phase of this lesson. Essential support systems for life. Oops, sorry, wrong one. Fourth part, interactions among tectonic events. Now, first of all, what do I mean by interactions? I mean, when you interact with a friend, you're talking with them, you're playing a basketball game with them, that's interaction, okay? Action coming together, action here and action here coming together, inter. Now, inter actually means outside of, and so interaction means action out coming together within, so that's interactions. Interactions among tectonic events. When we talk about tectonic events, we're talking about very large scale events. Now, what are some interactions that take place within large scale events or tectonic events in the Earth systems? Well, first of all, what are those tectonic events? Well, those tectonic events are solar events, okay? There's interactions of the gases that make up the sun. And solar flares are an example of tectonic events, very, very large scale events. We can fit several Earths inside of some of the interactions that take place within the sun in those flares. Okay? Tectonic events also include ocean circulation. Scientists now have the ability to look down from very high above the Earth and look at some of the systems and the movement that are going on throughout all of the different oceans of the Earth. Those are tectonic events. Another one is volcanic activity. Now, we looked at volcanoes just before we left for our extended vacation here, right? And volcanic activity is, by and large, very connected. Volcanoes are connected, and volcanic activity is called an interaction that's on a tectonic scale or a very large scale. Vegetation is another source of large-scale interaction on the Earth. Vegetation. What about precipitation? That is the falling of a form of water to the Earth. Precipitation is interactions among tectonic events, large-scale events. And then, of course, human activities, because there are so many of us on Earth. The activities that we participate in that are connected to the Earth are large-scale. And so those are interactions on a tectonic scale or a very large scale. Now, these can all cause large and really fast, really rapid changes to global and regional temperature patterns and precipitation. So these large-scale events cause massive change throughout the Earth and around the Earth. Okay? And again, we're going to be talking about how those changes occur, why they occur, what the reactions and results of those are when they do occur. So, to summarize this, the last two lessons, Earth is a complex system of interacting rock, water, air, and life. I hope you took good notes on the last lesson, 4.4, and on the last two videos that you saw with me giving a short mini lesson here. So we'll have a test on this this coming Friday. All right? Good luck.